In this video, we will be looking at the empirical rule. The empirical rule in example number 1, we're going to start with the systolic blood pressure of Americans has a mean of 123 millimeters per mercury and a standard deviation of 19 millimeters per mercury and follow the normal distribution. First, we're going to fill in the center, which is the mean, and then subtract a standard deviation 3 times from the center. Now add a standard deviation 3 times from the center. So first, we're going to figure out what those values will be on the number line. The mean is 123, so that is the center of the curve. Adding one standard deviation, which is 19, is 123 plus 19 is 142. Adding two standard deviations is 123 times plus 2 times 19, which is 161. And adding three standard deviations is 123 plus 3 times 19, which is 180. Subtracting one standard deviation is 123 minus 19 is 104. Subtracting two standard deviations is 123 minus 2 times 19 is 85. And subtracting three standard deviations, which is 123 minus 3 times 19, is equal to 66. Then you're going to draw a normal curve using the scale. Lastly, between one standard deviation of the mean is 68% of the data, between two standard deviations is 95% of the data, and between three standard deviations is 99.7% of the data. Here's the graph of the normal curve plotted on of the systolic blood pressure with 1, 2, and 3 standard deviations marked on the scale. So you can see we started with our scaling, 123 at the middle, went 120, 142, 161, 180 for 1, 2, and 3 standard deviations above, 104, 85, and 66 below, and then drew a normal curve over top of it, and then put in our probabilities. Now we're going to fill in the percentages we might want to have. Suppose you want to know a percentage between -1 standard deviation and 1 standard deviation, or between -2 standard deviations and -1 standard deviation, or any other region on the normal curve. This means that you need to figure out the percentages in the regions based on that empirical rule. So in example 2, let's say we want to find the percentage of Americans with systolic blood pressure between 123 and 142 millimeters per mercury. This is the region of the normal curve that is between the mean and 1 standard deviation. We go back to our curve for a second. That's this region here between the mean and 1 standard deviation. So this is between the mean and 1 standard deviation. On the normal curve, this is half the region between 1 standard deviation below and 1 standard deviation above. That is half of the 68%. So that percentage is 68% divided by 2 is equal to 34%. It's much easier to look at the percentages if one looks at the percentages of each of these pieces, such as what was looked at in example number 2. So think about how much of the normal curve is between, let's say, 2 and 3 standard deviations and above 3 standard deviations. In example 3, we're going to look at those. We're going to find the percentage of Americans with a systolic blood pressure between 142 and 161 millimeters per mercury. This involves a bit of problem solving. One knows that there's 95% of the blood pressures between 85 and 121 millimeters per mercury. Using the same logic in example number 2, that means that half of 95% of the Americans have a blood pressure between 123 and 161. So going back to our curve, That's between half of between 85 and the 161. So half of this region. So that gives 95% divided by 2 is equal to 47.5%. From example number 2, 34% is between 123 and 142. If 47.5 between 123 and 161, then the systolic blood pressure between 142 and 161 would be the 47.5 minus the 34% is equal to 13.4%. Looking at our normal curve, this area is 34%. This area is 47.5%. And so just this part here be that 47.5 minus the 34, which is the 13.4%. The normal curve is symmetric. So if 13.4% of the systolic blood pressures are between 142 and 161, then 13.4% of the systolic blood pressures are between 85 and 104 millimeters per mercury. Similarly, 34% of the systolic blood pressures are between 104 and 123. In the next example, example 4, find the percentage of Americans with a systolic blood pressure less than 142 millimeters per mercury. This is the region of the normal curve that is less than 1 standard deviation. On the normal curve, remember that half the curve below the mean is 50%. You know from example number 2 that 34% have a blood pressure between 123 and 142. So 50% minus, oh wait, sorry, plus, because we're adding, plus the 34% is 84%. Back at our normal curve, we're looking at 142. From 142 down. And we know that from here to, sorry, from here to here to here is 34%. And we know from here on down is 50%, and that's why we just added those together. In our next example, example 5, find the percentage of Americans with a systolic blood pressure more than 161 millimeters per mercury. This is the region of the normal curve that is everything above 2 standard deviations. On the normal curve, remember that half of the curve above the mean is 50%. You know from example 3 that 47.5% of the Americans have a systolic blood pressure between 123 and 161. So that means that 50% minus 47.5% equals 2.5% of Americans have a blood pressure more than 161. Again, looking at our graph, we know that this whole area is 50%, and we know from here to here is the 47.5%. So what we want is this area here, which is why we're taking the big 50 minus the 47.5. Again, because of symmetry, 2.5% of Americans have a systolic blood pressure below the 85 millimeters per mercury. Every normal curve follows the empirical rules. Do realize that these are just approximate values and that no variable matches the normal curve exactly. So all values are just estimates. It is easier to find the probabilities you want by drawing the normal curve with the percentages for each section written in them. The only two sections not figured out are the percentage of Americans with systolic blood pressure between 161 and 180. This area here, 161 to 180. It's the only one we don't know yet. That's the one we want to find. So, lastly, using the same logic from example 3, that would be 50%. I'm sorry. That would be 99.7% divided by 2, then minus the 47.5%. Again, going back to our picture, I know that this region here, from here to here, and from here to here, is the 99.7%. If I divide it in half, I get from here on up, here to here. And then if I subtract off the 50%, this percent here, which was the 47.5, that will give me the piece I have left over. So that is equal to 0.15%. Again, because of symmetry, 0.15% of Americans have a systolic blood pressure between 66 and 85. Lastly, the percentage of I apologize. That should be 99.7 minus 47.5 is actually 2.535%. I apologize, wrong answer here. So that's 2.35%, and so is this one. And lastly, the percentage of Americans with systolic blood pressure more than 180 is the 50% minus the 47.5%, which is 0.15%, actually. Sorry, that's 49. I apologize. I don't mean to be writing my answers wrong. I do apologize. So that's minus the 49.85%. So 50% minus 49.85% is 0.15%. Again, what that region is on our normal curve is we're looking for this little tiny region right here. And we know that this is the 99.7% divided by 2, and then minus the 50%, or the 50% minus that, sorry. I don't usually get these wrong, I apologize. So we're going to take that area there, and then to find the one we want the full 50% minus that area there, and that gives us, that's 49.85%, and that gives us this area right there. So that gives us a 0.15%. And again, because of symmetry, 0.15% of Americans have a systolic blood pressure below 66 millimeters per mercury. It helps to look at all of the normal curve with percentages of these small regions. So we have the 34%, 34%, the 13.6%, 2.1. These percentages are slightly different just because the software I was using does slightly different numbers. Just because of rounding, the 68, 95, and 99% are actually rounded a little bit. Now you can combine the percentages you need for the regions you want to be in. Note that every normal curve, the percentages are always the same. Just figure out what is the center is, which is the mean, and then add and subtract multiples of the standard deviation to find the separations of each percentage area.